What is reality? In the strange world of quantum mechanics, particles exist in multiple states at once, and observation determines outcomes. One man gave us the equation that defines this world, forever changing how we understand the universe. This is the story of Erwin Schrödinger, the father of quantum wave mechanics. Born in 1887 in Vienna, Austria, Erwin Schrödinger grew up fascinated by mathematics, philosophy, and the mysteries of nature. As a student, he quickly proved himself a brilliant thinker, excelling in both theoretical and experimental physics. But his early career was interrupted by World War I. Serving as an artillery officer, Schrödinger never lost sight of his passion for physics. After the war, he returned to academia, determined to uncover the fundamental laws of the universe. In the 1920s, physics was at a turning point. Classical mechanics could not explain the strange behavior of electrons inside atoms. A new theory was needed, one that could describe the dual nature of particles as both waves and matter. Then, in 1926, Schrödinger proposed a revolutionary idea: what if particles weren't just tiny objects, but also waves? He formulated the Schrödinger equation, a mathematical description of how quantum states evolve over time. This equation showed that instead of following precise paths, electrons exist as probability waves, spread out across space. It was a beautiful, elegant solution, but it also raised deep philosophical questions. Not everyone was satisfied with quantum mechanics' strange implications, including Schrödinger himself. If particles existed in multiple states at once, then what did that mean for the nature of reality itself? To illustrate this absurdity, Schrödinger proposed a thought experiment. Imagine a cat inside a box with a vial of poison triggered by a quantum event. Until we look inside, the cat is both alive and dead, a paradox that highlights the bizarre nature of quantum superposition. The experiment wasn't meant to prove quantum mechanics, it was meant to question it. How could reality exist in multiple states until observed? This paradox continues to fuel debate about consciousness, measurement, and the nature of the universe itself. Despite his reservations about quantum mechanics, Schrödinger's contributions were undeniable. In 1933, he was awarded the Nobel Prize in Physics for his groundbreaking work on wave mechanics, cementing his place in history. But history took a dark turn. As fascism spread across Europe, Schrödinger, opposed to the Nazi regime, fled Austria. He eventually settled in Ireland, where he continued his research, exploring ideas beyond quantum mechanics, including the origins of life itself. Schrödinger wasn't just a physicist, he was a thinker who dared to cross scientific boundaries. In 1944, he wrote What is Life? A book that explored how quantum mechanics could explain the mysteries of biology. His ideas directly influenced the discovery of DNA structure, showing that physics and biology were more connected than anyone had imagined. Today, Schrödinger's equation is used in everything from quantum computing to chemistry, from semiconductor design to artificial intelligence. His work helped shape the modern world, proving that the universe is far stranger and more beautiful than we ever imagined. Even in his final years, Schrödinger continued to push boundaries, contemplating the mysteries of quantum entanglement, what Einstein once called spooky action at a distance. Erwin Schrödinger was more than a physicist, he was a philosopher, a visionary, a man who dared to challenge the very nature of reality. He left us not just with equations, but with questions, ones that scientists are still trying to answer today.